on this computer, and then I'll be able to post that. Okay, so, and then sharing screen. Group 1, you are up.
Okay, so we had water and coconut water. And our claim was that the more mass the substance has, the larger the gravitational force Earth exerts on it. Our evidence was this graph where we got trend lines of the water and the coconut water. And we averaged out everyone's analyses so that we could get the best representation of what it was. And our reasoning was that the coconut water has a slightly larger mass at a given volume than water does, and therefore weighs more than water does. Every 0.31 kilograms of water weighs on average 3.1 newtons, whereas also who spelled whereas wrong? Was that Danielle? Coconut water has 3.025 newtons per 0.2975 kilograms. So
Wow.
coconut water weighs more.
Okay. Anybody else wants to add anything from their group? Okay.
Also, design credits go to Eloise.
Thank you.
Thank you for giving credit when credit is due. Okay, room 2.
Well, our claim was that the more mass applied on water and the rice, the more gravitational force is on water and rice. And as you see here in our graph, for water, every kilogram of mass, you add 9.45 newtons. In rice, every kilogram of mass, you add 5.171 newtons.
Okay. Yeah.
Oh, I was just say our evidence was the chart. I mean the the graph with our data, and then our reasoning was as the x-axis increases, the y-axis also increases.
Which in math speak is, we said the slope is positive. But you're right. All of what you said is true. Okay, room 3.
So for our claim, every time 1 kilogram is added, the water increases by 9.45 newtons.
And kind of the same thing for the flour. So every time 1 kilogram is added, the flour increases by 9.49 newtons.
Anybody wants to like wordsmith that claim a little bit? I really like the specificity of the claim, by the way. I think it's really cool. What does it mean that the flour increases by 9.49? What does it mean that the flour is increasing by 9.49 newtons? What can increase by 9.49 newtons?
The force.
The force, right? So it's the force on the flour that's increasing by 9.49 newtons, right? So the gravitational pull is increasing. Okay, group 4.
So we had 2 claims. The first one is a water claim, an increase of 1 kilogram in water causes the increase of 9.45 newtons of force.
Mm-hmm.
And our sugar claim, an increase of 1 kilogram of sugar causes an increase of 4.8 newtons of force.
Got it. Okay. And group 5.
So our claim was similar. So we had our substances were water and pancake mix.
Mm-hmm.
And so our claim for water was for every 1 kilogram of mass, there's 9.45 newtons. And so our claim for the pancake mix is for every 1 kilogram of mass, there's 9.61 newtons. And basically we got this from the equation of the graph. As you can see on like the top of the graph, there's an equation for water. It's like next to like that blue line at the top.
Mm-hmm.
And then we also have the equation for the pancake mix. And yeah, so it also has like a positive slope, meaning that there's like an increase in both the y and the x-axis.
Okay, love it. So here's a question for you all. Look at frame number, so look at picture number 5, right? Taking the picture, the two lines almost overlap, mostly because they have the same slope. So they're kind of parallel, right? But they're super close. And that's for water and pancake mix. As opposed to, let's take this one, for example, water and sugar, where the slopes are pretty different. In fact, one is twice as big as the other. So can we live with that? Is that okay? I mean, hey, you know, sugar is different from pancake mix, so what the heck, right? Or is there like some more profound problem? What do we think? Yeah, Lowell.
I think it's just because sugar has like less mass than pancake mix, and therefore like the force of gravity, like, or there's less of a force of gravity on the sugar than there is on the pancake mix. But I could be wrong.
Okay, but I mean, like, look at this graph. So what it's telling you is that for 0.2 kilograms of, right, for 0.2 kilograms of pancake mix of sugar, there is about 1 Newton of force, right? That's for 0.2 kilograms. If you look at this one, for 0.2 kilograms of pancake mix, it's 2 Newtons. Question, is there any difference between 0.2 kilograms of pancake mix and 0.2 kilograms of sugar? Yeah, Isabel.
It's like no, it's like the same problem. Like, would you rather have 100 pounds of feathers or 100 pounds of bricks? They weigh the same, but
Yeah.
the amount of space they take up is different.
So how much space they take is going to be completely different. Agreed, right? Like violently agree with you. So which brings me back to my question. If you have the same mass of pancake mix and sugar, should you have the same force? Jude? Jude says no.
Well, I think pancake mix is like a lot denser just because like sugar's like kind of sugar crystal, so it doesn't take up all the space, but pancake mix is like a fine powder, so it's definitely a lot denser.
So it's going to take a different volume. Agreed. Like possibly, right? Like that's possible. But is it going to have less gravitational force on it?
If they're the same amount of kilograms, no, but like if like you go to like an equal amount of newtons on sugar and pancake mix, that'd give you different weights, I think.
Okay,
Or,
you said if their masses are the same, their forces should be the same. Yeah? Did you just say that?
yeah.
Okay, so Avery, based on that, what do you think about the results? If their force, so Jude said, if their masses are the same, the forces on them should be the same. You agree with that? What do you think?
The mass is the same, so.
So this graph would say that's not the case. And that graph would say Jude is right. Same mass, same force. So what do we think?
I guess, yeah, maybe. Sure.
Sure, why not? Okay, let's quick vote because so they should be the same. 1, they should be different. 2, quick vote from everybody. 1, they're the same. 2, they're different. 1, they're the same. 2, they're different. And keep your finger up. 1, they're the same. 2, they're different. 1, they're the same. 2, they're different. Isabel's like switching back and forth. Like, I think it's 1, maybe not. I don't know. Marin, vote. 1. Yeah, you're right. It is the same, right? If you have the same amount of mass, it's not like the Earth knows that it's pulling on like pancake mix or whatever. The Earth feels an object of a certain amount of mass, right? and it knows like, oh, this is how hefty it is, and it pulls on it with a certain amount of force. It doesn't care that it's salt or water or anything. All it cares is that there's a mass and it's pulling on it. So it should be the same. So the fact that it's not the same means that maybe there were mistakes. And we can talk about like what kind of mistakes, right? We don't know. Maybe the density was wrong when we calculated the mass. Maybe, I have no idea, right? So I'm going to stop sharing. I am also going to stop recording.